Hello and welcome to Just Have a Think, and the third in a series of programmes looking at the detail of the IPCC Special Report that came out back at the start of October. This week we're focusing on transitions, and specifically in energy use and land and ecosystem management. The report also looks at urban infrastructure and industrial systems, which we'll have a look at in a later programme. So let's take energy transitions first, which most of us understand to be the move to renewable energy technologies. The report states that renewable energy has seen considerable advances over the years, but solar energy and both onshore and offshore wind energy have had dramatic growth trajectories. The largest growth driver has been the dramatic reduction in the cost of solar photovoltaic panels, and this has made rooftop solar competitive in sunny areas between 45 degrees north and 45 degrees south, and it's starting to look cost effective in many other places too. Folks in many rural and developing areas are already making really effective use of solar panels combined with battery storage. For example, 19 million people in Bangladesh now have solar battery electricity in remote villages and are reporting positive experiences on safety and ease of use. Bear in mind that most of these people were using kerosene lamps in their homes before solar and battery storage came along, so not only is the solar power more or less free once you bought the kit, but the air these people are breathing inside their homes is far less dangerous, and there's far less chance of them burning their homes to the ground, which was quite a common occurrence previously. But the report warns that public acceptance remains an important factor in the feasibility of renewable technologies, in particular for wind energy and other large-scale renewable facilities. The NIMBY instinct of "not in my backyard" still exists in many people's minds. If a big facility goes up in a particular area, then people in that area can feel a sense of geographical injustice. The report finds that when a community is engaged properly in the process of implementation right at the start, and people feel like they're being offered a financial as well as a vocal stake in the project, then resistance tends to melt away. Essentially, if you can watch your electricity bill plummet to virtually zero, then you're quite likely to very quickly grow to love the elegant silhouette of three blades turning gently at the top of a tower on the horizon. Estimates vary about just how much of our energy can eventually come from renewables, but several countries have adopted targets of 100% renewable electricity. Up next in the report is nuclear energy. Like it or not, nuclear power is not a fossil fuel based power source, so it doesn't contribute to CO2 emissions. Having said that, of course, as we all know, the downsides of nuclear power are not insignificant. After the 2011 Fukushima nuclear disaster, Japan's Prime Minister called for a dramatic reduction in Japan's reliance on nuclear power, and Taiwan's president did the same. Nuclear power currently provides about 11% of the world's electricity. The quicker that renewable energy can be implemented globally, the quicker these countries can move away from nuclear power for good. Regardless of the initial power generation method, a crucial transitional priority is the adaptation of existing electricity systems to cope with 1.5 degrees Celsius or more of average global temperature rises. The report reminds us that climate change has started to disrupt electricity generation, and if climate change adaptation options are not considered, it's predicted that these disruptions will be lengthier and more frequent. The report strongly concludes that these impacts need to be planned for in the design of any kind of energy infrastructure, especially where there's interdependence with other sectors that require electricity to function, like water, data, telecommunications, and transport. We need look no further than Puerto Rico's experience with Hurricane Maria back in 2017 to see how vulnerable a single central power producer can be in extreme climate conditions. The main strategy here is redundancy and multiple supply sources. In the words of the report, the implementation of controllable and islandable microgrids, including the use of residential batteries, can increase resiliency, especially after extreme weather events. Systems that take advantage of an array of sources will by definition be more able to cope with climate impacts. Household micro-generation from rooftop solar and other technologies, all feeding into a smart distributed energy grid stretching out across continents, effectively means that energy is constantly flowing through the system from millions of tiny inputs rather than from a single massive central power plant. Someone arriving home in the dark at 7 p.m. in Bucharest or Boston can cook their evening meal in their oven using electricity that's still being generated by solar power in the daylight at 5 p.m. out in Lisbon or 4 p.m. in Los Angeles, where people are still at work and energy use is low. This will smooth out the spikes in demand and make energy systems much more resilient. And then household battery storage, quite possibly in the form of an electric vehicle parked outside your home, will take up any remaining slack. Now we arrive at a couple of technologies that are absolutely crucial to the IPCC RCP modelling graphs achieving their projected temperature limitations, but both of which are not without their skeptics. I'm talking about biomass and carbon capture. Biomass is developed from organic materials like scrap lumber, forest debris, certain crop types like soy and corn, manure, and some types of waste residues. It splits down even further into bioenergy, which is renewable energy from burning biomass directly, essentially only emitting the carbon dioxide that the plant recently drew out of the atmosphere to photosynthesize and grow, so in theory, a carbon neutral energy source. And then there's biofuel, which is refined liquid ethanol derived from biomass and used in transport. Biomass is an entire program all of its own, which we'll have a look at in the new year. But the concern around biomass is in the type of crops used and the type and extent of land used to grow those crops. If we just cut down loads of forests to make land for growing these biomass crops, then obviously that's completely pointless. And if we turn over lots of existing high quality agricultural land to grow these crops and then only grow one crop on that land, then we're going to face exactly the same problems with soil degradation that big agriculture face today. So this is quite a thorny one. Here's what the report says about it. Sustainable bioenergy potential in 2050 would be restricted to around 100 exajoules per year. Sustainable deployment at this or higher levels envisioned by 1.5 degrees Celsius consistent pathways may put significant pressure on available land, food production and prices, preservation of ecosystems and biodiversity, as well as potential water and nutrient constraints. So biofuels have to be regarded as very much a suboptimal choice, although far less bad than fossil fuels themselves. And then there's carbon capture and storage. I touched on this back in Programme 8 when we looked at geoengineering. The fossil fuel industry and big construction materials producers like steel and cement are keen to develop carbon capture because it basically allows them to carry on their current production practices more or less unchanged. But the technology is very difficult to achieve in any kind of economical way, so there are practically no plants in existence that have this system working at full scale. In fact, according to the report, 2 CCS projects in the power sector capture 2.4 megatons of CO2 annually. Well, that's 2.4 million tonnes of carbon dioxide captured versus 40,000 million tonnes of carbon dioxide emitted by human beings every year. I'll let you decide whether that constitutes a meaningful contribution. On the other hand, bioenergy in carbon capture, or BECCS, is heavily featured as a negative emissions technology in the IPCC RCP models. The idea here is that you grow your crops, which use a bunch of atmospheric CO2 in photosynthesis to grow. You burn those crops, use the heat to generate electricity, or maybe something useful like a community heating system, but capture the carbon dioxide that the combustion process produces and shove it far underground where it remains locked up for thousands of years. This would, in theory, be a negative carbon technology, actually removing carbon dioxide from the atmosphere. And while we're on about Earth and crops, let's have a think about land and ecosystem transitions, which also feature quite heavily in the IPCC report. Even in a 1.5 degrees Celsius warmer world, local crop yields are projected to decrease in tropical regions that are major food producing areas of the world, like West Africa, Southeast Asia, South Asia, and Central and Northern South America. The increased temperatures, even at 1.5 degrees C, would affect the production of cereals, which in turn will have a significant impact on global food security. At 2 degrees Celsius of local warming and above, aggregate production of wheat, maize and rice are expected to decrease in both temperate regions and tropical regions. So that's all these areas. Here's the report's findings. These production losses could be lowered if adaptation measures are taken, such as developing varieties better adapted to changing climate conditions. Bioenergy and biotechnology can also serve to reduce emissions intensity and the carbon footprint of food production. A secondary transitional agricultural strategy is called conservation agriculture, The soil is carefully managed with minimal tillage to reduce the disruption of the soil structure and the billions of microbiological processes that go on all the time, processes that are invisible to us humans, but which are absolutely vital to the health of a soil and its ability to nourish crops as they grow. These no-till practices, combined with good crop rotation, work particularly well in water-limited areas. And by adjusting planting times, varying crop selection and improving irrigation efficiency, the report suggests that we could increase wheat and maize yields by 7 to 12% even in climate change conditions. This form of agriculture also raises soil carbon content, which means it removes more CO2 from the atmosphere. And then there's the massive elephant in the room, which is actually a massive herd of cattle. Livestock are responsible for more greenhouse gas emissions than all other food sources at about 7.1 billion tonnes of CO2 per year, which is 14.5% of all global human greenhouse gas emissions. Beef and cow's milk are responsible for about 2/3 of that total, largely due to methane emissions resulting from the cattle's digestive systems. This is the one that everyone seems to shy away from talking about, but the fact remains that a dramatic decrease in our red meat intake would have as big an impact, if not bigger impact, on climate change than eradicating all the fossil fuels from our road vehicles. Here's a key quote from the report. Dietary shifts could contribute 1/5 of the mitigation needed to hold warming below 2 degrees Celsius with 1/4 of low-cost options. In other words, a mass global move towards plant-based diets would eradicate 20% of the climate change problem overnight. In reality, of course, while relatively wealthy Westerners like me are moving to vegan diets in their droves, myself included, the prevailing trend is for increasing, not decreasing, demand for livestock-based products on a global scale. Way back in Programme 4, we discussed the fact that eating meat is still seen as a sign of economic progress in third world countries, so this remains arguably as big a behavioural change challenge as the move away from fossil fuels. And the utterly profligate way in which we manage food loss and waste, particularly in the West, is a huge contributor to completely unnecessary and avoidable global greenhouse gas emissions. Around 1/3 of the food produced all over the planet is not consumed. Food wastage alone could increase emissions by an estimated 2 to 2.5 billion tonnes of CO2 every single year. So decreasing food waste has high mitigation and adaptation potential, as long as, and this is an important caveat, as long as the reductions in food wastage result in lower emissions coming from the food producers rather than the consumers just eating the existing food more efficiently. So what about the biotechnologies like the dreaded genetic modification, or even these latest news stories we hear about the lab-grown beef and other foodstuffs? Apparently the most exciting gene modification process is something called CRISPR-Cas9. Obviously I was keen to find out what the acronym CRISPR stood for, and now I slightly wish I hadn't bothered asking in the first place, because it stands for Clustered Regularly Interspaced Short Palindromic Repeats. Essentially, it's gene modification that makes crops more resistant to viruses. Here's the IPCC's assessment. Such genome editing tools may moderately assist in mitigation and adaptation of agriculture in relation to climate changes, CO2 elevation, drought, and flooding. These tools could contribute to developing new plant varieties that can adapt to warming of 1.5 degrees Celsius and overshoot, potentially avoiding some of the costs of crop shifting. However, biosafety concerns and government regulatory systems can be a major barrier to the use of these tools, as this increases the time and cost of turning scientific discoveries into ready applicable technologies. There doesn't seem to be any IPCC assessment of the really experimental lab-grown foods like these burgers, probably because there's insufficient real-world evidence of public perception and uptake, as well as whether there are any health implications. But this one could really be a game changer on a global scale. There'll obviously be hundreds of millions of people who simply will not want to give up eating meat. So if these technologies are scalable, then we could liberate massive areas of land in key areas of the globe, which leads us very nicely to forests and other ecosystems. According to the report, tropical forests contain 1,085 billion tonnes of CO2. Subtropical forests hold 194 billion tonnes, temperate forests 176 billion tonnes, and boreal biomes 190 billion tonnes. So conservation and restoration of these natural carbon sinks seems like an extremely good idea. Much of the literature that the IPCC assessed focuses on RED+, which stands for Reducing Emissions from Deforestation and Degradation. We looked at RED+ in Programme 16 in Part 3 of a series focusing on the United Nations' first ever annual climate report released earlier this year. That report told us deforestation and forest degradation account for approximately 17% of global carbon dioxide emissions, more than the transport sector. RED+ is an international initiative to reduce these emissions, foster conservation and enhancement of forest carbon stocks, and promote sustainable forest management. It's a great concept with loads of potential which hasn't yet been fully embraced all over the world, but it's been beset by corruption in many countries, especially in Indonesia, where bribery and coercion are unfortunately just a way of life. Last but not least on this week's modest little to-do list are transitions in coastal management. As sea levels rise, we'll have to allow for the landward migration of coastal ecosystems, which means the indigenous peoples on those coastlines will have to significantly alter the way they live and work. And then we'll also need to transition towards the restoration of coastal ecosystems and fisheries. Restoring marine ecosystems is much more expensive and difficult to do than restoring land-based ecosystems, and attempts at doing so have historically been fairly unsuccessful. Replanting mangroves does look like being one of the more successful global strategies, with numerous examples of projects that have established forests. By contrast, heartbreakingly, efforts to rebuild and restore coral reefs have mostly ended in failure. Technologies to re-establish coral communities are quite limited, as are largely untested disruptive technologies like genetic manipulation and what the scientists call assisted evolution. According to the report, current technologies also have trouble getting these things up to scale because of the huge costs involved and the apparent complete lack of interest from governments and commercial operations. So once again, a huge amount to take in and quite a few things to note down on Mr. Guterres' little to-do list. So let's see what we've got. We've got internationally coordinated implementation of energy storage for greater electrical grid resilience. We want internationally coordinated agricultural and land management policy to include mandatory reforestation legislation in the relevant regions. We want coordinated public health education programs in Western industrialised countries to minimise food waste, backed by government and food industry. And we need coastline management policies in vulnerable geographic locations. Next week we'll have a look at the crucial transitions that we'll all need to make in our urban infrastructure and industrial systems. That's it for this week though. Please do subscribe and hit the notification bell to get alerted when the new programs come out, and you can do that by clicking this link here. As always, thank you very much for watching. Have a great week, and remember to just have a think. See you next week.